You know, something that Albert Einstein used to love saying was, don't memorize, derive. Instead of memorizing things, derive them when you need them. I'm going to teach you how to derive two very special triangles from which we'll be able to evaluate many trigonometric functions. All right, the first one I'm going to show you is how to derive the 30, 60, 90 degree triangle. Now, there are just a couple of steps involved. The first step is to draw an equilateral triangle. Equilateral means the sides are all the same distance. So here's my triangle with equal sides and equal angles. So I'm labeling all of the sides 2. I could label them all 1 or 3 or 4, but I'm labeling them 2 for convenience, and you'll see why later. They all have to have the same distance, equilateral, and then they have to have the same angles. All of them are the same. They're 60 degrees, 60 degrees, and of course the last one's going to be 60 degrees because they have to add up to 180 degrees. But I'm going to cut the triangle, the equilateral triangle, in half, right down from the top to the bottom. And when I do that, it cuts the 60 degree angle at the top into two 30 degree angles. And the bottom, I have a right triangle. So what I've done is I've formed two right triangles, one on the left and one on the right. And since I've cut the bottom in half, each of these two little triangles have a bottom base, a measure of 1. Now the next thing we want to do is do the cutting in half and just throw away one of them and keep half of the equilateral triangle. So it's a right triangle, and it has one distance on the bottom, 60 degree on the bottom, 2 distance on the side, 30 degree on the top, and then we'll have to use Pythagorean theorem to come up with the missing leg. The missing leg, well, you know Pythagoras says that hypotenuse squared equals leg squared, leg squared. Well, I want one of the legs, so I have to solve Pythagoras for one of the legs. The leg is equal to the square root of the hypotenuse squared minus the other leg squared. So this side is equal to the square root of 2 squared minus 1 squared, which is equal to the square root of 3. So that gives me the following 30, 60, 90 degree triangle. 90, 60, 30. Sides are 1, 2, square root of 3. That's a 30, 60, 90 triangle. And you either are going to need to memorize that, or you're going to be able to to draw it up just like I did here from scratch, starting with an equilateral triangle with angles 60, 60, 60, sides 2, 2, 2, cut it in half, discard one of the halves, and use Pythagoras to find the missing leg. And now you have your 30, 60, 90 degree angle triangle. Okay, one more we're going to make is the 45, 45, 90 triangle. In this one, instead of starting with an equilateral triangle, we start with a square with side 1. A square has the same side on all 4 sides, the same distance. So side 1, top is going to, so here's our square, same distance for the sides and the top and bottom. They're all distance 1. And we're going to cut it diagonally in half. Cut this cubic square, a square that has the same measure all the way around, 1, 1, 1, 1. Cut it diagonally in half. Now, all of the angles when we started were 90 degree angles, right? They all met at a 90 degree angle. We just cut 2 of those angles in half. So what's half of 90 degrees? 45. So you see the lower half has 90 degree angle at the bottom, but the 2 side angles are 45 degrees. I'll throw away the top, and turn this thing, bring this thing down and use Pythagoras to come up with the missing side. So we've got 1 for the legs, 45, 45, 90. So use Pythagoras to find the hypotenuse. Hypotenuse equals the square root of leg squared plus leg squared. 1 squared plus 1 squared, which is equal to the square root of 2. So that gives us our final product, the 45, 45, 90 triangle. It's right angle, distance 1, 1 on the legs, 45, 45 on the 2 adjacent opposite angles, and then the square root of 2 on the hypotenuse. That is our 45, 45, 90 degree triangle. Either memorize that thing in the cloud or remember how to derive it from a perfect square with sides 1.